So very good evening to one and all. Very good evening to one and all. Thank you for your presence. I think my voice is clear. Very good evening to Bharatra Singh. Is my voice is clear? Can anyone respond in chat box? Is my voice is clear? Can anyone respond in chat box? So very good evening to one and all. Thank you for your presence. Today we are gonna see on-chip protocol of like AHB, Advanced High Performance Bus Protocol. It is also comes under the AMBA protocols. We already seen the APB protocol. Today we are gonna see AHB protocol. So K7, very good evening. Thank you for your response in chat box. So thank you for response, Bharatra Singh. And then thank you for your daily presence. So let's wait for a few minutes and then we can start the session. So today we are gonna see the basic description, basic specification about this AHB protocol. It is an important protocol for SoC, system on chip, and also some of the microcontrollers and then some of the processors like i7, i5. They are using this protocol for on chip communication. So very good evening to Sri Krishnan. Very good evening. So let's wait for a few minutes and then we can start the class. We can start the session. So thank you. So Wilson Paul, very good evening. So it is a very important protocol like AXI, APP, all the protocols, UART, I2C, SPI, and then coming to the on-chip protocol like APB, AXI, AHB. All the protocols are very important. Based on this protocol only, the actual data are transferring inside the chip and also outside the chip. Okay. So based on these protocols, based on this logic, so based on the protocol signals, based on the standardized methodologies and then standardized functionalities of protocol, we can using the reliable data communication, data transferring. Okay, if it is there is no protocol, means there is no reliable data transfer. Okay. So and then Vaishnavi PV, very good evening. So let's wait for a few more minutes and then we can start the class. I hope you guys understand the APP protocol. We already seen APP protocol specification, and then we already yesterday class also we seen APB slave design code, and then SystemVerilog test bench architecture for APB, that code. So that's till now we seen only APB protocol. Today we are gonna see AHB protocol. Okay. So I hope you guys are clear with what is the on-chip communication, what is the on-chip protocol, what is the off-chip protocol. If you guys are clear with the on-chip, off-chip protocol, means just put S in chat box. Okay, I think we can start the class now. Okay, we'll start with the firstly basic transfers, how the data transfers happens in the protocols. So before going to that, what are the kinds of signal declaration in the waveform? So these are waveform definitions for the signal definition. So signal definition, for example, assume like you having one signal. If the signals are having the 50% of on time, 50% of off time, it is always toggling, means it is known as clock. So this is a representation of the clock, and then this is a representation of the high to low line. It will changing from high to low. This is one line. It is named as high to low. So where these all are using means, for example, if you take like a I2C protocol. So while clock is high, if the data transfer, if the STL line is in the I2C protocol, when the clock is high, if the STL line changes from high to low, means it's a start condition. So on that time it is very important. So we have to know all the signal, all the waveform definitions. Okay. So this is one kind of information. So this very important thing. So this symbol, this is known as clock. This is known as the high to low transition. This is known as waveform of transit. Transit means the data are transferring continuously. Okay. So and then this is high to low. So this is a waveform definition for high to low, and this is refers as stable signal. If the signal having this waveform window in my output means I can say that it is a stable signal, and so it is an bus to high impedance. So if the line in the center means it is known as high impedance. So and then here this transition happens means we can say that it's a bus change. Okay. And then high impedance to stable bus. So you can see here in startingly it having the center line. So and then it is known as unknown. So it is known as high impedance, but after some time it will changing to stable state. So we can say that it is an high impedance to stable state of bus. So these are the basic information you have to know while seeing the waveform output. Okay. So and then this is about of protocol. So here we are going to see AHB protocol. So AHB, so we know that AHB is high speed protocol. It having the high bandwidth. So it's mostly used for inside the chip to make the high speed communication, high speed data transferring between the blocks inside the SOCs. So AHB stands for Advanced High Performance Bus Protocol. Okay. So AMBA, it is comes under the AMBA protocols. So it is a bus interface suitable for high performance synthesizable designs. So it defines the interface between the components such as manager, interconnect, subordinate. So here the manager is refers to master, the subordinate is refers to slave. So and then interconnect is nothing but it will make some connection between the master and the slave. For example, if you are having the multi-master, multi-slave. So multi-master, multi-slave means you are having the multiple AHB masters, you are having the multiple AHB slaves. So on that time, so for in the I2C protocol there is an option called arbitration, but here we having the something called interconnect. It will make connection between, it will make communication between the manager and subordinate. So manager is refers to master, subordinate is refers to slave device. So it is an bus transfer, it is a single edge operation. So we know that APB protocol it will take 2 clock cycle for one transfer. So in the AHB protocol it will take only 1 cycle to make transfers. Okay. So it is very important protocol. So as you are looking for VLSI career, if you want to interested, you are interested in to learn the VLSI communication protocol means it is very mandatory protocol to learn the bus transfer, pipeline transfer. These all things are started from the AHB protocol only. So we know that in the APB on-chip protocol we don't have bus kind of transfer, we don't have pipeline, but here in the AHB protocol it having the bus kind of bus transfer and also pipeline transfer. It is an high speed protocol. So assume like in the 1 clock cycle it can send 128 bits. So by using this AHB protocol you can send 128 bit of data to receiver in 1 clock okay, in 1 clock cycle you can send 128 bit data. So assume like how much data you can send and also how much speed is there. So we know that if you are having the 50 megahertz of clock means if you assume like you are having the 50 megahertz of clock, so from the 50 megahertz of clock you can count 5 crore times within 1 second. So in 1 second you can count 5 crore times by using the 50 megahertz of clock. So it means 5 crore clock cycles, 5 crore passages, and then each and every passages you can send 128 bit of data. Okay. So it means how much it's fast, and then how much data you can send. There is a 128 is a not like a small data, it's like a big data. Okay. So for example, our computers are running with 32-bit and then 64-bit data transferring only. So if you are while installing the, if you are using some applications, it will ask your computer version whether it is 32-bit or 64-bit. So until now we are running with the laptop computers with 64-bit only, but you can send up to 128-bit data. Okay, so you can transfer the 128-bit data by using this AHB protocol. So what I am telling means that much it is an important protocol for the VLS engineer. Okay, it is an high speed protocol. So and then one more thing is for 50 minutes of clock you can send you having the 5 crore clock cycles in the 50 minutes of clock, 50 megahertz of clock. But assume like you having the 4 gigahertz of clock, it means 4000 megahertz of clock. How much clock cycles you have in the 1 second? Okay, for 50 minutes of clock you having the 5 crore clock cycles. Assume like you having the 4 gigahertz. For 1 second, how many clock cycle you have? So it will more than crores, lakhs of crores. Okay, so lakhs of crores, it having clock cycles for 1 second. So that's why there is a backend, there is a main reason why this is how based on this only we are increasing our speed. So now we are connecting with YouTube live session. So what I am speaking to you, you will receive within some less delay, like a 1 second or delay or 2 second delay, but there is a speed. Okay, there is how much speed we are communicating. So this is the main thing of speed, data communication. So this so I am speaking to you by using my computer. My computer will receive the data from me by using the mic, and then the chip will transfer to the antenna, and then antenna will send to the receiver. Your device, it having some antenna, and then it will receive my data, and then it will decode, it will encrypt, and then it will do something, and then it will display, it will give your audio, it will give audio output of me. So this flow, this standard transmitting happens very fastly, means by based on these kind of protocols only. Without this high speed protocol we can't achieve this kind of high speed communications now we are using. Okay, so this is the main thing of AHB APBN protocol. Then there is this is a AHB protocol. We having the burst, we having the single clock edge operation, and also non-tri-state implementation, and then configurable data bus width, and then configurable address bus width. So if you wondering about how the cell phones are working speed, so it will work with the cell phone speed. Our mobile phone speed is equal to computer speed. So some of the computers like i5 is having the same speed as your mobile phone. So if you compare, means the main thing is it having the high speed protocol. So our mobile phones also having the high speed protocols inside the chip. So based on this protocol only we are using the mobile phones with the high speed. Okay, high speed communications. So this is a main protocol. And also AXA also another protocol. It is as AXA is advanced version of AHB protocol. Okay, so we'll see in the upcoming classes how that what is the spec of the AXA protocol. So today we are going to see AHB only. So it is a bus transfer. So coming, I will explain what is a bus transfer, what is a pipeline, and then it is a single clock edge operation. I already said no. And then it is a non-tri-state implementation, and then it is a configurable data bus width. So configurable data bus width is nothing but, so you can configure that. So how many data you can send, whether you can send 8 bit of data, or else you can send 32 bit of data, or you can send also 64 bit of data in one transfer. So this is configurable. So this is known as configurable. So you can configure your data width in this protocol, but in the APB protocol you don't have any option. Okay, why? Because of it already fixed. So like a APB signal, yesterday also we seen address is 32 bit, and then the data also 32 bit, and then output is also 32 bit. So in the APB protocol you can send only 32 bit of data to receiver, or else you can make communication by using APB protocol. You can send or receive only 32 bit of data, but you can but here in the AHB protocol you can send up to 128 bit, and also you can configurable. So you can send 32 bit, you can send 48 bit, and then you can for 64 bit, and then you can send also 128 bit. So this is our wish. So and then same like data, you can also give the configurable address bus width. Okay, you can also give the configurable address bus width. So this is a main thing of AHB protocol. So bus transfer pipeline, single clock cycle it will need for make one transfer, and then data bus and then address bus you can configurable, you can change the size of the bit width. Okay. So and then already said no usages. So it is mostly used for high speed communications. It's like a external memory interface, high speed bandwidth peripherals, and then internal memory devices. So and then interconnect components provide arbitration. So this the main thing is, assume like you having the SoC. So if you having Samsung phone means it having the Exynos SoC, Exynos chip. It is like a SoC kind only. So it having the CPU cores, it having the it having some modem. So modem is one kind of plug inside our SoC. So modem it will perform the 5G communication, 4G communication kind of thing. So the communication data transferring between the CPU core to modem, we can use the AXA protocol, or else you can also use AHB protocol. So this is a real-time example of AHB protocol. Okay. So and then so very good evening Narayana Murthy, Radha Kumar, Varalakshmi, very good evening, thank you for your daily presence. So Yamnath, Sampath, very good evening, Venkata, very good evening. So thank you for your presence. So and then there is a black diagram of AHB protocol. So assume like the manager. So here this manager is reference master. These subordinates are refers as slave devices. Okay, it having one master, multiple slave devices. So so how the data transfer happening this, like from one master to multiple slave. So before going to that, you have to know the signal names, signal list of this communication. Okay, so in the APB protocol we are using the P prefix to define this signal is refers to APB protocol, but here in the AHB protocol we have to use H prefix to define this signal is belongs to AHB protocol. So because of we know that SoC having using the multiple protocols. So if you are using the same name means you may receive some conflict. It is very hard to write the design code. So that we are using some prefix kind of techniques to differentiate the signals from the protocols. APB means P prefix. In the AHB means HEC prefix. Okay. So and then so this is a main black diagram of the AHB protocol. It having the one master, multiple slaves. So you can see here HW data. It means H write data, APB write data, APB address signal 32 bit. So we can also increase and decrease by using the another signals kind H trans, H burst. We will see one by one what are the signals is there. Okay. And then this is the why I am using decoder means here I am having the multiple slaves. So how but at a time we can make communication only one subordinate, one slave only. So to select the slave we are using some decoder options. So so in the address it having some part of signals. It is used for decoder operation. The decoder will decode the slave device. Based on the HCL signal we can select which we can choose the master can choose the slave device to communicate with that. Okay, with them. So this is how the decoder is used for choosing the slave. And then this mux operation, it's why I am using means the output of slave. So output of subordinates it given to the master. So it is a basic thing. So if the master needs some output signal from the slave means by using this mux, the master can get the results. How it can means it having the multiplex. So we know that mux is two, like a mux is a number of multiple inputs and then one output. There is a basic work of mux. It having multiple inputs, but based on the select line, it will give the output. So you can see here it having the three outputs from the three slave devices. So by using this mux selection line, it will give the output. So this is how the basic digital electronics are used for VLSI. So that's why it is very important to learn basics of digital electronics, like a combinational circuits, sequential circuits, mux, demux, encoder, decoder, and then priority encoder, and then adder, ripple carry adder, and also coming to sequential means flip-flops, latches, and then counters, registers, and then these are the basic thing we have to know. Then only by using this kind of knowledge only we can make the design code. We can use the logic in our projects, in our protocols. So here I am using the decoder and then mux logic to make the to select the slave and also to get the data from the slave. By using these two kind of decoder and then mux logic, I can select this data from the slave, and also I can give the data. I can select the slave devices also by using decoder. So I think I hope you guys are clear with this AHB black diagram, and then I will move into the manager. So there is a manager. So we'll see the basic signals of manager. So I already said no, APB having only limited number of signals, but in the AHP it having the multiple signals. There's a version of AHP protocols, AHP 3, AHP 5, AHP Lite. So there are a lot of there are versions of AHP protocols. Okay, so this is a basic black diagram of AHP protocols. It having the signals like H reset, it is an active low reset, H clock, H ready, H response, HR data. These signals comes from the AHP slave device. Though these signals are output of slave device, and also it is an input for the master, okay, manager. Okay, these signals are refers as output of manager, okay, master. Like a H address, H write, H size, and then H burst, and then HP rot. It's like a H protection signal, H trans. So the H master lock, and then H double data. So these are the basic signals of AHB protocol. Okay, just a minute. So just a minute. Okay, so again we can continue. So these are the basic signals for the master. Okay, so and then the main thing is here also master will initiate the process. So master will start the master only will start the data transfer. Okay, and then we'll see the subordinate. A subordinate respond to the transfer initiated by the manager, so master in the system. The subordinate uses the HLX select the signal from the decoder to convert when it respond to the master transfer. The subordinate signal back to manager, the completion of or extension of bus transfer, and then success or failure from the bus transfer. The main thing is subordinate is a subordinate. The master can select the subordinate by using the decoder. And then the decoder it having some slave addresses. Based on the slave address only the master can communicate with the slave. And then so slave device having some power. So what power means? The slave device can send the message to master like I need some time, and then if it is any error means the slave device can send to master. And also the completion of data or extension of bus transfer is depends on the slave only. Okay, subordinate only. It is a slave response, subordinate response to the master. Okay, here subordinate slave are mostly same only, same thing, and then manager master are same only, so don't confuse that. And then success or failure, it is also slave response to the master. Okay, So and there we will see the slave side of subordinate side of AHB protocol. So these are the input for the subordinate: clock, reset, selection, slave address, and then address, write, and then size of the transfer, burst, and then protection signal, transfer type, master lock, ready, HTTP data. So these are the basic signals of the uh, subordinate slave device. This is the input signal for the slave. Then this is output signals: ready out, and then H response, and then HR data. So this is a basic output of HHP protocol from the slave. So by using these two signals, H ready, H response, this is a two output signal for the slave, and it is act as a input for the master. Okay. So and then we'll move into the interconnect. So interconnect, we already seen that this is interconnect. So we are doing some interconnect operation. We are interconnecting the master and the slave by using the decoder and the multiplexer. This is interconnect. Okay, this is the role of the interconnect, like a decoder and multiplexer. Okay. So and then before going to that, if you guys are really interested in this master class, you can convert into this master class into 1 month of internship program. You will get the benefits like you will get these all 8 benefits, all 30 days recording sessions, all PPTs you can also download, and then you will get the 4+ exclusive projects like AHB, APB, AXI, I2C, UART, this kind of communication protocols you will get. And also you can also get the source code, and then you will get the confirmation letter from the IETE, and also you will get the 180 days of LMS access, and then you will get the assignment and task, and then you will get the internship report, and then you will get the high valued certificate from internship certificate from IETE. So these are the benefits you will get at just discounted fee of just 999. Our regular fee is 499. In this masterclass period we are giving our internship program with just 999. So if you guys are really interested, you can convert in this masterclass into 1 month of internship program. So if you want to convert, means you can use this link. This is a internship registration link. By using this link you can register for internship, and also you will see this window. Here you have to choose advanced VLSI design and verification. Okay, so then this is a sample certificate you will get at the end of 1 month of internship program. Okay, so and then we'll see the operation. So and then I already said no, this is an pipeline operation. Okay, so pipeline operation is nothing but it will do some overlapping operations. So the manager starts the transfer by driving the address and control signals. Okay, so it having the 3 types of operations, like a single incrementing burst that do not wrap at address boundaries, and then wrapping burst that wrap at particular address boundaries. So what is defining increment in the wrapping means, so you have one memory, like you have assume like memory, you are continuously writing into memory, means you have to give the address data. So if you increase the address, means you can continuously write into memory. This is how the incrementing burst operation will work. And then if you are using, so the what is defining wrapping burst means, so you will give some boundaries, like for example address is 10, it will increase by, it will address 10, address 11, address 12, 13, 14, 15. If it reaches the 16, means it will start from the address 11. So this is known as wrapping address and wrapping data. So this is the basic thing of incrementing and wrapping around. So we'll see one by one in the upcoming classes. The main thing is incrementing, means it will automatically increment at the end of the boundaries. But here in the wrapping burst, wrapping the transfer, it will reach the boundary again, it will start from the initial address. Okay, there is a main difference between the incrementing and then wrapping around. Okay, so write data bus moves data from manager to subordinate, and then read data bus moves from subordinate to manager. It's like a write means manager to slave, read means we can slave read from the master, read from the slave to master. So write means master to slave, read means slave to master. So it having the two phase, like address phase and then data phase. Okay, so main thing is in the 1 clock cycle the AHB protocol can do both address operation can do send address and also can send data also. So for example, you are doing some write operation by using the AHB protocol. You are doing some write operation in the one clock cycle. You can send address also, you can send also data. Okay, this is a main thing of operations. You can send address, you can send also data by using in this protocol. Within one, in the one passage, you can send the data to slave, you can also send data to slave, sorry, address to slave. So this is known as address phase, data phase. So in the both address phase, data phase, we can do in the one clock cycle. So address phase, one address and then control cycle, and the data phase means one or more cycles for data. So and then this is the main thing of the AHB protocol transfers. So and then response, H response, it is a subordinate signal. So you can see here response signal. It is saying that if it is high means there is no if it is high means there is an error in the transfer. If it is low means there is no error. By using the, if this is a single bit signal, H response, HRESP. If it is high means there is an error, if it is low means there is no error. Okay, so and then ready signal is known as slave response. Slave is ready to make transfer. So and then, so these are basic signals we having in the AHB protocol. The signals are H clock, H reset 10, H address, H trans, H write, H size, H burst, H protectional, HP ROT, and then HW data, and then HR data, H ready, H response, H split, H bus required, and then H grant, H and then lock. So it having these kind of this much signals. So while writing the design code, we have to use these all the signals. Okay, so by using these signals only we can make the reliable AHB protocol. So we have to use, so and then there is a directions. So each and every signal is having some direction, whether it may be master to slave or slave to master, and also it having width means data bit width. Okay, bit width. Okay, so we'll see one by one what is the direction, then what is the width of the signal, and then description of the signal. We know that clock means it's a clock signal 1 bit width, reset is also 1 bit width, and then H address. So both master and slave needs clock, synchronized same frequency clock. Okay, if both are different clock domain means it is comes under that clock domain tracing. We have to use something called synchronizer, like a FIFO buffer kind of thing. And also, so we'll see the address. So address is a 32 bit width by default, and then trans is a 2 bit width, H site is a 1 bit width, H size is a 3 bit width. So H size is refers. So by using, you can see here H trans. This is one signal. So it will say the type of the transfer. So transfer is nothing but it having some types like ideal, BC, non-sequence, sequence. So that by using trans signal we can define the which type of the transfer it having. So and then write means if it is high means write, if it is low means read. And then size, it means H size is refers to size of the transfer. Size of the transfer is nothing but it may be byte, it may be offered, it may be word. So before going to that, I want to know one thing: how many people are aware of the term word? So you have you know the word meaning? So I am using here word, byte, offered, word means. Can anyone respond in chat box what is the mean of word? So what is this is a technical term, so do you know the term meaning of the word? So what it is mean, the word term is what it defines. Can anyone respond in chat box? So can anyone respond in chat box what the word this word term defines? So can anyone respond in chat box? So what is the meaning of the term word? This word offered. Can anyone respond in chat box? The term, I think I can say. Just if you know means just put answer in chat box or else I can say. So byte equal to 8 bits. Half byte means, so sorry, half word means the word is 60. No, not Naradamurti. Word is 16-bit data. No, no, it's not correct. 8-bit. No, not 8-bit. So byte means 8-bit of data. Half word means 16-bit of data, and then word means 32-bit of data, and then double word means 64-bit of data. So it having up to 28-bit. Okay, I will. This is the main thing. So word means 32-bit of data. Okay. Byte means 8-bit. Half word means 16-bit. Word means 32-bit of data. Okay, it's clear now. So and then edge protection, it's a protection control signal. It having some modes, and then write data. Yeah, 32-bit of data. Correct. Thank you for response, Naranamurthy. So and then HWD is a write data, and then H ready is a slave indicates if it is ready to complete the transfer. Okay. And then H response already so no. If it is 0 means okay, no error. Or 1 means there is an error. If the signal is, if the H response signal having 0 means there is no error. Okay, to transfer. If the whatever the master sends to slave, the slave receives correctly, there is no error. So if it is H response, HRESP signal, HRESP, if the HRESP signal having the high means there is an error in the transfer. Okay, and then H split is a slave to master signal used to slave to split the transaction. Okay, transaction is nothing but transfer. And then grant signal, log signal, this kind of grant, log, bus required, these kind of signals are we are mostly we don't use. But this main signal is H trans, H size, H burst, and then H double data, H write, and then H response, and then H ready, H address, H reset, H clock. These are main signals. And coming to the H burst, it will say the burst type. Coming to the H size, it will say the how many bit we can send the data, we can transfer the data. In one clock cycle, how many data we can send means by it is depends on H size only. Okay. Okay. Thank you for response in chat box, Annamalai, Anamurthy. So and then we seen the input and output signals. So and then we'll move to the deep diving into signals. H trans, it having the 2-bit, it means 00011011. So it will define, if it is 00 means it is an idle transfer, if it is 01 means it is an busy. Okay, if it is 10 means non-sequence, if it is 11 means sequence. So while writing the code, this will helpful for to define the transfer types. Okay. And then H burst, so it is like a burst type. If it is it is a 3-bit signal. If it is having the 00 means it is a single transfer, it means 8-bit of data, 8 bit. If it is 00 means increment burst by undefined length, and then if it is 01 means wrapping around 4 beats. So I will tell you what is a beat. Okay. So coming to the beat, firstly you have to know the burst. So what is the burst? So burst is a combination of the bytes. For example, you can say that how many beats it having. Okay. So before going to the know the burst means you have to know the beats. So what is the beat means? So I already said no H size. If it is, we can give the size of the beat. 1 beat equal to 8 byte data. It means we can assign the size of the beat. For example, if you are assign like a byte means that 1 beat it having the 8-bit of data. If you assign like a half word, it means 16-bit. It means for 1 bit it having the 16-bit of data. So we can assign the data with for the beat. Okay, for 1 bit 16-bit, for 1 bit it having the 32-bit. It means we can assign the width, like a bit width for the beat by using the H size signal. Okay. This is a beat. And then what is a burst means? The combination of a 4 bit is known as 1 burst, and then 8 bit is also we can say like one burst. It means for combination of bit is known as burst, and then bit means we can define the size of the bit, whether it can be it is start from the 8 bit, and then 16 bit, 32 bit, 64 bit, 128 bit. Okay, so this is how we can define the H burst by using these kind of signals. If it is 0 0 means single transfer, if it is 0 1 means increment, if it is 0 1 0 means so wrap around. Okay, if it is 0 1 1 means so 4 bit means, if assume like a 1 bit it having the 8 bit of data. If the 4 bit means 8 into 4 32, so it having the 32 bit of data in the one transfer. So and then this is the main thing of the AHB. Cycle 1 address phase, cycle 2 data phase. If H ready is 1 means the slave is ready, next data transfer can occur. If H ready equals 0 means the master must have to wait for the slave to complete. So and then it will having some lot of content today. I think it's clear for you. It means there are a lot of things we have to take in our mind, like these kind of signals, interconnect, and then address phase, data phase, this much of values like H trans, H size, burst, word, beats. So it will be very easy to understand. I think we can stop now for this AHB protocol. We can continue the remaining topics tomorrow. I think till now you guys are clear with my class session. If any doubt means you can ask now. So this is for today. So we will see the remaining topics tomorrow. Why? Because of if I take this whole protocol to one day means definitely you will forget. So it will. So we have to go slow. Then only we can understand more. Okay. So thank you guys. Thank you for watching this session. So if you have any doubt means you can ask now. And then this is for today. So thank you for response, Bharat Singh. So thank you, Pranav. So we'll see tomorrow with the remaining topics of AHB protocol and then coding part also. Thank you guys. Thank you for listening. Good night.